All right, hello students. Time to talk about some topics from Chapter 1, the structure and stability of atoms. A variety of things that are basics when we're taking this textbook from the approach that's called Atoms First. We'll begin with atoms. The chemistry of the elements is our first section here. We're talking about the names and symbols of common elements. You can tell readily, I suspect, that some of these names feel far more simple than others, and that some of them are clearly related to their symbols and some of them are not. The ones in the left three columns of this table are elements which have names that at least resemble their symbols, and the ones in the right column are those which have Latin origins, and those are far less obvious to us, but we get used to them gradually. Each element has a symbol that has one or two letters. The first one is always capitalized. The elements shown in this picture here are not named and labeled per se, but they are mercury, which is not a simple name, and silver, which is again related to a Latin name, and sulfur. Well, sulfur is the easiest one of those three. Fair enough. Just examples of what they look like. When we're thinking about the periodic table, it is a very cleverly derived table. It's interesting, the history. This is kind of there's a number of history lessons in this chapter. Mendeleev was a Russian scientist who lived in the 1800s, and with the knowledge he had at his resources at the time, he was able to come up with a chart that lives largely intact today. His periodic table that was published in approximately 1871 used information on the elements, many elements known at the time, and in fact predicted other elements that were not yet known. And those were later turned out to be actually very accurate predictions. He assumed there had to be another element that was heavier than aluminum, that these were arranged in part by mass, that had properties like aluminum, and that turned out to be gallium, and that there was another element heavier than silicon but similar properties, and that was later verified to be germanium. Interesting things they were able to predict in those times with the lack of sophistication that we commonly think is normal today. The elements in the periodic table are organized in a fashion what makes a lot of sense and is very helpful to us once we become acquainted. There are a number of aspects that we need to know about. So let's look at the terminology. Periods. These are the horizontal groupings, and so periods are numbered 1 through 7 along the left of this particular diagram. In addition, there are groups, and groups are either main groups. Whoops, I was trying to change color for you. There you go. Main groups are the left and right larger, taller columns, and then the other part that is not the main groups are the transition metal groups, and then these are also named as intertransition metals, but they're not labeled on this particular diagram. And having these labeled, the groups are going to be vertical orientations. And so vertical groupings of elements in groups have different names. We'll get to some of their names gradually. With this periodic table view, you can also see that there is the chemical symbol for every element is at the bottom of each square, and its atomic number is at the top of the square. Some periodic tables will certainly have more information than is shown on this one, but this is common to essentially all periodic tables. Mostly, but sometimes there's simplifications. The color coding on here represents the different categories of elements, and the key is shown at the bottom. Metals are going to be the gray shaded boxes, which as you can see is a huge majority of the elements. So most elements are indeed metals, and they have the kind of characteristics that you think of when you think of keys and coins. They are going to be hard and shiny. The semi-metals are in orangey or tan colored. I don't know how that appears on your view, but it's kind of orangey tan shaded box. There's only a limited number of semi-metals, and they're in a zigzag pattern towards the right. We'll talk about more of them gradually. And so those are the semi-metals in the middle of the right section. And then the reddish color, those are mostly red, these colors are funny, are the non-metals, and they are one kind of triangular portion of the chart, purely on the right end. Oh, with one exception, hydrogen belongs in that group, in that category as well. So there's 3 broad categories here. We'll describe each of them to some extent as we go through the chapter. So there are common groups of elements and the properties that we need to think about with each of them. Properties are going to be characteristics that we'll be using to describe or identifying these different things. And there's 2 subcategories for these properties. They're either going to be intensive properties or extensive properties. Intensive and extensive is not something we always talk about, but it's sometimes informative to think about these things as the way we use them in identifying and describing matter. The intensive properties do not depend on how much the sample is present. So you're measuring the temperature of something. Doesn't matter how much it is, it has a temperature. Or the melting point. It's a characteristic for a specific substance. It doesn't matter where you've got a handful or a bucketful, it's going to have the same melting point, assuming it's the same compound or substance. Extensive properties do depend on the sample size. So it depends on how much is there, what kind of length or volume something is going to have. So intensive and extensive properties are sometimes helpful in our being able to describe what's going on. But these things can be used to help us identify things. Physical properties and chemical properties are 2 other categories, and we need to be familiar with the differences and similarities between them. The physical properties are characteristics that do not involve any change in a sample's chemical makeup. In other words, the chemical formulas do not change when the physical properties change. So examples of that are shown on the left of this table. Things like the temperature and the color of things are going to change. Perhaps the melting point is a physical thing. The amount, the odor, the solubility, it's still the same substance regardless of which of these things you're looking at and describing. Electrical conductivity and hardness also fit there. They're physical properties. Nothing is changing in a chemical formula when we're looking at these kinds of properties. The chemical properties are different then, because these changes in characteristics are going to change a chemical formula. So let's make a note here. No change, that's what the symbol means, in chemical formulas. And the chemical change, by contrast, is definitely a change in chemical formula. So what changes a chemical formula? Chemical changes do. Chemistry is going on when you rust something, when gasoline is burned, when something tarnishes because it's been exposed to air like silver does, or hardening of cement, interestingly, is a chemical change. Some folks are more familiar with some of these examples than others. Okay, now, as we move forward then, we're going to talk about some of the named groups in the periodic table that we need to become familiar with. The first of which is the alkali metals. The alkali metals are described as having a group number of, whoops, hang on a minute. Sorry about that, let me fix that. Alkali metals are in the leftmost column of the periodic table, labeled as group 1A. 1A is one symbol of, or set of numbers. Sometimes you'll see the numbers that are 1 through 18, and the simpler set of numbers is to just describe them as 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. That's for the main groups. When we're numbering the main groups, we can number them with numbers up to 8 with A after them. So 1A is the alkali metals. Why alkali? Because when they react with water, they make basic solutions. That's another word for basic is alkaline. Sodium. Sodium would be the third square down in that chart, in that group here. And it reacts very violently in water, makes a flame. And other alkali metals do something similar. And that's characteristic of that group. The next group down, or the next group over, pardon me, is the alkaline earth metals. They are in what we describe as group 2A. Group 2, group 2A. And the alkaline earth metals are again going to make alkaline solutions, which is why they're called alkali, but they're less reactive, not as violently reactive as alkali metals, their neighbors. But they do burn in air to make oxides, and the picture shown here represents a strip of magnesium, which burns very, very brightly when you once ignite it. So those are elements that are in group 2A. Magnesium would be the one that's the second square, second space down in group 2A. So alkali metals, alkaline earth metals, two groups to know. Groups are always vertical. The halogens is the next named group, and that is group 7A, and otherwise on numbers 1 to 18 is sometimes listed as 17. The halogens are very colorful and oxidizing compounds. In other words, they can be somewhat hazardous. Because of that, they're seldom found in their pure forms, and they're going to react readily with metals to make things like halides. Of course, the most common salt that these halides represent would be something like sodium chloride. Sodium chloride is a halide salt of sodium with chlorine. Chlorine is, of course, the third row down here. I'll make it a mark it there. Chlorine is there, and the picture on the right shows bromine, which is below chlorine in that column of the halogens. Halogens gets their name because they make halides, generating halides. That's what halogen means. Group 7A. All right, next group is the one to the right of that, is the noble gases. The noble gases are colorless gases with very little chemical reactivity, and for that reason they are called inert. Inert as in don't do very much. Little reactivity. Is very only extreme reaction conditions will produce compounds with noble gases. Most of them won't be found in compounds except for in strange examples. They're obviously something we've seen in things like neon signs. Neon is the second one of the noble gases, and neon signs are familiar in that respect. So that's one of the things they're known for, being able to be used in such ways. That's group 8A. So groups 1A, 2A, 7A, 8A have names that we need to be familiar with. Now, other things to know about parts and groups within the periodic table are naming and describing metals. Well, like I mentioned a little bit ago, metals are what you think about. They're shiny solids, except for mercury. Mercury is a liquid. And so I always ask people to think in terms of things in your pocket, like keys and coins and metal cookware. Those are all things that have characteristics that are similar to most metals. They're shiny solids. They conduct heat. That's why they're used in cookware. They conduct electricity. That's why they'll be used in wires too. And they are going to be malleable. That's how you make coins. You pound it into sheets. That's what malleable means. And so many metals are used to make coins and other sheet-shaped things, such as aluminum foil, for one. All right, so metals are clearly a huge fraction of the periodic table, and a majority of elements, in fact, are there. They sit next to those next groups that we will describe subsequently. Here's some nice pictures of shiny solids. So lead is a duller colored one. Aluminum is very shiny, like you think of in sheets. Gold can be found in various forms. This one looks like little turnings of gold. This is gold here. Sorry to not name them more clearly. That's gold. That's lead. And they both have Latin names. Copper is in the middle, and copper is shown in copper strips. And iron, who knew that would be iron? Yes, that happens to be iron, which is a hard, shiny solid. Depends on how much you polish it, how shiny it is. And that last one is magnesium. And it's shown in little strips. So you can have them in different forms, but they are capable of being shiny solids. Okay, nonmetals. Well, here's some pictures and some examples. Now, don't forget the one odd exception. Nonmetals are, in general, on the right side of the periodic table in that triangular section to the right of the zigzag line that defines the metalloids. But the one that you have to add to that is hydrogen. Hydrogen is on the left with the metals, but it is surely not a shiny, hard substance. It is a gas. And so the nonmetals do include hydrogen. It's kind of deceptive. Some periodic tables will represent it in more places than just group 1A for the reasons that it does have properties of the nonmetals, but for other reasons it sits with group 1A. We'll talk about those with time. So nonmetals have properties that are contrasting with those of the metals. They aren't shiny, they are more brittle, and they're lousy electrical conductors. So their properties are kind of opposite of what we think of for metals. These are, again, only physical properties. We'll talk about chemical properties with time as we get there. In this picture, we have representation of bromine, which is a liquid, and it has a lot of vapors that make for a very colorful looking vapor above the liquid in the flask. This is carbon. Doesn't look like much, but it might be exactly what you find in your pencils, called graphite, in your mechanical pencils, or any pencil, but sometimes we see them more in mechanical pencils. Phosphorus is a red solid, hardly shiny, not a bit. And sulfur was shown somewhere earlier, but sulfur is a yellowish powder, shown in this picture as well. So those are examples of nonmetals. Where do they each find themselves on this side of the periodic table? Well, let's double check. Carbon is here, and bromine is right here, and sulfur is not quite under. Oh, I put carbon in the wrong spot. Hello, don't do that. Sorry, get it right. I'm thinking backwards when I put it there. Carbon belongs in group 4, and sulfur belongs in group 6. And phosphorus is next to it in group 5. There we go. Pay attention. Looking at it wrong. All right, what group shall we talk about next? Guess which one we haven't done? Well, it would be the semimetals, also known as metalloids. Oh, my text boxes didn't line up correctly. Sorry about that. The semimetals have intermediate properties. Their physical properties are somewhere between the metals and the nonmetals. And they are similar to the nonmetals in having brittle and poor conducting characteristics, but they don't generalize as well. You may have heard of silicon semiconductors because they are somewhat conducting, but sometimes not, and they can be used as insulators for that reason. These are kind of tricky to find because they lie along that funny zigzag line, and I'm going to mark it in here so you can see it. The zigzag line goes between aluminum and silicon, because aluminum is truly a metal just the way you think it is. It goes between silicon and germanium, and it's totally zigzag all the way down the periodic table here. Astatine is included if you want to get technical for metalloids, but it is very rare to ever run into a sample of it anywhere in the universe practically, so it's sort of an odd one to include. So generally, if the element lies on two sides, it touches two sides of the zigzag, it will be a metalloid. Semimetal is also known as a metalloid. That's one way to think about it. Okay, they don't generalize too consistently. It's kind of tricky there. All right. So this would be the end of this recording. Good luck studying chemistry.